All right, folks, so we now have all three sides of this triangle. Now, to determine the trig ratios, which is what so, ka, and to mean, we are going to use the side relationships relative to a given angle. So that's one of the key things with this is we always start by identifying which angle we are looking at. Well, angle B is labeled as our theta, so that's the angle we are looking at. Next, we determine the side relationships to that angle for B, C, and A. What would you say C is relative to theta? Is it opposite, adjacent, or hypotenuse?
Adjacent.
It is adjacent, but what is it more? It's the hypotenuse. So normally when I am labeling, I always start by labeling the hypotenuse side, which is always across from the 90-degree angle and always your longest side. 3, 4, 5 is longest. There's your hypotenuse. Now, what about side A relative to that angle? Is it opposite from theta or adjacent? It's adjacent. It's right next to the angle or making the angle. So side A would be the adjacent side. So then what about B that's across from it? That's going to be your opposite side. So opposite, adjacent, and hypotenuse. And now we are going to use those sides to structure our trig relationships. So sine of theta is opposite over hypotenuse. That's the so part of SOHCAHTOA. The O means the opposite side goes on the top and the hypotenuse side goes on the bottom. So what would sine of theta be equal to? 3, the opposite side, over 5, the hypotenuse side. So sine of theta is 3/5. Cosine is the ka part of SOHCAHTOA, which says cosine of the angle is A, the adjacent side, divided by H, the hypotenuse side. So C-A-H, ka, sine, so S-O-H. And what is the adjacent side to theta? 4, and the hypotenuse side? Then tangent of theta is the toa part of SOHCAHTOA, or opposite over adjacent. So the opposite side to theta over the adjacent side would be 3 over 4. Raise your hand if this is starting to come back to you a little bit from geometry. How does it seem so far? Easy or pretty hard? Do you remember learning it in geometry though, and wasn't it like the hardest thing ever? Because isn't it one of like the last things you guys do in geometry? So like your spatial perception has gotten better, your just organization of math concepts has gotten better. So I'm hoping that even though this is the last unit and it is after break, this should go fairly easily for us. So we're going to go ahead and jump into example 1. It says find the 3 trigonometric functions for the value of theta. So on this problem, we've got all 3 of our sides. We've got side C is 17 because that's across from angle C. What's 15? Side B or side A? B, because it's across from angle B. And then what about 8? That's going to be A. So I've already got all 3 sides here. So I don't have to use the Pythagorean theorem to find a missing side. So if I want to find sine of theta, we first mark the angle that we are looking at. The angle that we are looking at is A. Next, we want to determine who's the opposite side, who's the adjacent side, and who's the hypotenuse side. I would start with the hypotenuse side since it's always going to be the same. Who is our hypotenuse? C, or 17. Always across from the right angle, always the longest side. So that's my hypotenuse. What would you say 15 is relative to theta? Is it adjacent to the angle or opposite the angle? Adjacent. There's my adjacent side. And then 8 then is
opposite the angle. So it's like the angle is kind of chomping or eating that side. There's my opposite side. So sine, cosine, and tangent for that angle, so, ka, toa. Sine is going to be the opposite side over the hypotenuse side, or 8 opposite over 17 hypotenuse. Cosine is the ka part of SOHCAHTOA, so the adjacent side, 15, over the hypotenuse side, 17. And then toa, tangent, is the opposite side, 8, over the adjacent side, 15. Now, what if we switched which angle we were looking at? What if instead of looking at angle A as theta, what if we looked at angle B as theta? Does this affect our sine, cosine, and tangent? Our hypotenuse is still 17. That's still the longest side. That's still our hypotenuse. But what is 15 relative to B? Is it opposite, adjacent, or hypotenuse? It's opposite. And then what is 8 relative to angle B? It's adjacent. So this is why, folks, we always start by identifying which angle we are looking at, because that's going to affect the side relationships to that angle. So if I wanted to find the sine of B, the opposite side would be 15, and the hypotenuse side would be 17. Same relationship, opposite over hypotenuse, but it changes depending which angle we are looking at. So we always start with the angle, determine the side relationships, and then it's SOHCAHTOA. Let's go ahead and practice drawing the general right triangle. We're going to go ahead and label him down here, the general right triangle. You can draw it justified any way you like, but I do tend to draw it with the right angle down in the left corner. And I usually kind of draw it as kind of isosceles, because when you're drawing diagrams for this, the accuracy of the diagram doesn't really matter. It's more about the organization of the sides relative to the angles. So what does the right angle have to be labeled as? C, so that the side opposite from it is little c. So the hypotenuse has to be C. Why? Because in the Pythagorean theorem, C has to be your hypotenuse. Now, angle A and side A, if you put angle A up here, side A would be across from it, and angle B would be here with side B across from it. But it doesn't actually matter. You could put angle A up here, you could put angle A down there, just so long as the corresponding side is across from it. I'm going to do angle A up there, side A across from it, angle B down in the corner, side B across from it. So I would put an important box around this, because this diagram you will have to know how to generate. So right angle is C, hypotenuse is C.
So we're going to go ahead and see what we can make out of example 2. We aren't explicitly given a diagram here. We're just told that the sine of angle B is 5/8. If sine of B is 5/8, what is 5? Opposite, adjacent, or hypotenuse? Opposite. So sine is the so part of SOHCAHTOA. So sine of the angle is opposite over hypotenuse. So let's go ahead and draw out what we know with this triangle. So we're going to practice drawing and labeling the general right triangle. Angle C is the right angle. Side C is the hypotenuse across from it. Angle A, side A across from it. Angle B, side B across from it.
And which angle are we marking? Which angle are we looking at? Angle B. So I'm going to mark that angle. And now we are going to determine the side relationships to that angle. Who's our hypotenuse? C. C is always the hypotenuse. Who's our opposite side? B. So opposite, across from it. So there's our opposite. So then who's our adjacent side? A. And again, the hypotenuse is adjacent to B too, but we always have to have those three side labels: opposite, adjacent, and hypotenuse. So now, what do we know from our given information? We know that our opposite side is 5. So B is 5. And we know our hypotenuse side is 8. Now, if we want to find the two remaining trig functions of B, what are we going to need to find? We're going to need to find A, or the adjacent side. So what do we use to find that? The Pythagorean theorem. So use the Pythagorean theorem to find missing side. So A squared plus B squared equals C squared. Now, a conversation I always have to have with the pre-cal kids is, can I just square root that whole equation and say A plus B is C? Can't do it. If we could, we definitely would. If I don't have to mess around with those exponents of 2, it'd be really nice if I didn't have to. It has to be the squares of all of those sides. So A squared plus my B squared is 5 squared, or 25. And my C squared is 8 squared, or 64. So A squared plus 25 equals 64. A squared is 39. Square root, square root. Ooh, are there any perfect squares I can take out of 39? That's a big part of this term test, because remember, simplifying radicals was a big deal. There are no perfect squares. So A, side A, is just radical 39. Gross. So now let's practice writing the trig relationships. Sine was given to us, but here's what students tend to write, and it's not quite right.
Why is it not sine of 5/8? You have to write the angle. It seems fussy, but as we showed above, depending on what angle you're looking at, the trig relationships will change. So you have to include the angle name. It's not just sine is 5/8, it's sine of B equals 5/8. So I want you to write, you must write the angle. I'll be picky about that on the homework quiz. I will be picky about that on the test. So sine of B is 5/8. Cosine of B and tangent of B. Cosine is the ka part of SOHCAHTOA. SOHCAHTOA. So our adjacent side is rad 39. Ugh. Over our hypotenuse side, which is 8. Yuck. I know the bell schedule is even less than I did. 12:15. 12:15 for us. So sine of B is 5/8. Cosine of B is rad 39 over 8. Tangent is the TOA part of SOHCAHTOA. So our opposite side is 5 over our adjacent side, which is rad 39. Is your pre-break gut telling you anything about this? Can't have a radical in the denominator. Oh no. So back to unit 7, question mark. How do we get rid of a radical in the denominator? We need to multiply it by 1. We don't want to change the value of it. What can I multiply a radical by so that it goes away?
itself as the creative form of 1. So if we multiply by rad 39 over rad 39, we go straight across and we get 5 rad 39 all over square root of 39 times the square root of 39 gives me some awful perfect square whose square root is 39. So tangent of B is this. So I would just put a note as a reminder. No radicals in the denominator. We have to rationalize all of those. So no radicals in the denominator.
What questions do we have so far? Pythagorean theorem, so the TOA. I think we'll go ahead and pause there for right now and maybe take some time to go over our tests before we break for lunch. So we'll go ahead and stop.